The top 5 geochemical techniques every prospecting geologist should know. Hey rockhounds and resource explorers, welcome back to the channel. Modern mineral exploration isn't about aimlessly drilling holes. It's a high-stakes, data-driven science. If you're not using the sharpest geochemical tools, you're essentially leaving millions of dollars of copper, gold, or nickel hidden underground. Today, we're recutting through the noise and giving you the top 5 geochemical techniques every prospecting geologist needs in their toolkit, with special emphasis on one ingenious method we call safe geology. 1. The foundation. Strategic soil sampling. Every successful discovery begins, quite literally, in the dirt. Soil and rock chip geochemistry are among the most tried and true methods in exploration. But ditch the blanket coverage, we're talking strategy. Bypassing thorough soil sampling is a guaranteed way to waste vast sums on unproductive drilling. Companies that implement rigorous sampling show success rates exceeding 60%, compared to the measly 15% seen by those who skip this foundational step. If you drill based only on a hunch, you're likely to end up with a hole full of nothing. The key is sampling the right layer. You need to penetrate the organic rich surface, horizon A, and target the transitional B horizon, where elements like cobalt and zinc are enriched, or the C horizon, which is composed of weathered bedrock closest to the original source. This systematic approach filters prospective areas early, guiding where the big drills should go later. 2. Reading the rocks. Lithogeochemistry and pathfinders. When you move past the soil, you move into the rock. Lithogeochemistry is the analysis of the rock's actual chemical composition. Technology alone is fantastic, but it's worthless without solid geologic knowledge. You have to pay attention to the rocks. In large hydrothermal systems, such as Porphyry Copper Systems, elements distribute themselves along thermal and pH gradients. We chase not just the main commodity like copper, but the subtle pathfinder elements and economic tracers like antimony, arsenic, and thallium. These pathfinders often disperse far wider than the main deposit, forming huge geochemical footprints that guide us back to the core. Sometimes, geology plays tricks. You might find low-temperature pathfinder elements where they are not supposed to be, right over the middle of a copper system. This usually signifies a telescope system, where later, cooler alteration at the temperature parasitic overprint has been superimposed over the original high-temperature core. By combining rock geochemistry with an understanding of these alteration assemblages, you can vector right into the heart of the ore body. 3. Real-time decisions with Portable XRF pXRF. Next up is the technology that has completely revolutionized speed in the field, the Portable X-ray Fluorescence Device, or pXRF. These handheld instruments can quantify up to 25 elements in minutes, giving field teams real-time geochemistry. But here is the million-dollar question we geologists always debate. Should we powder the rock sample first, or measure the core directly? While powdering homogenizes the sample, the research shows that for non-mineralized, fine-grained rock cores, powdering generally offers no significant gain in instrumental precision or accuracy compared to measuring the core in situ. If your goal is generating high spatial resolution downhole elemental profiles across entire drill holes, crushing the core isn't practical or allowed. The solution is simple. Take multiple measurements, 3 to 7 points minimum across the unprepared core, and average them. This practice quickly improves the data quality to acceptable levels for most geological applications, making it fit for purpose without destroying the core or wasting precious field time. Think of it as real-time chemical logging, almost like a geochemistry wireline log. 4. Practice safe geology. Heavy mineral concentration now for the secret weapon. We call this technique safe geology, and it directly solves a major problem in sampling, the nugget effect. Especially common with gold, gold is rarely evenly distributed. It occurs as scattered particles, meaning a tiny scoop of bulk material might contain 0 gold, or hit a single large particle, yielding a wildly inaccurate result. The typical soil or stream sample you collect is 90% waste material that carries no useful information. The core idea of safe geology is heavy mineral separation, on the fly, to enrich the sample before lab analysis. We're concentrating the heavy, valuable fraction on purpose. How? It's basically advanced, rapid panning. You introduce the sample material to water and perform a vertical, circular motion to sort the minerals by specific gravity. The heavy fraction, the good stuff, sinks to the bottom, and the light waste material, clays and lighter silicates, rises and can be discarded. This process boosts the concentration of indicator elements significantly, ensuring that even if you miss a gold particle in the bulk sample, the other heavy pathfinders are concentrated and detected. Crucially, you must sample smart, choose sites where the stream water slows down and heavy minerals naturally concentrate, such as the inside of meanders or immediately upstream of natural obstructions like fallen trees. 5. The future. Isotope tracing, the new geophysics. Finally, let's talk about the cutting edge. Geochemistry is increasingly being referred to as the new geophysics. Why? Because we are gathering massive, multi-element datasets that reveal patterns akin to geophysical anomalies across mineral systems. The most advanced technique here is isotope tracing. Using sophisticated instrumentation, ultracollector ICP-MS, geologists can trace the real footprint of buried ore deposits. Isotopes allow us to understand the precise geochemical and redox mechanisms, the specific chemical processes that cause elements to mobilize and deposit during primary and secondary dispersion. Isotope analysis is moving beyond traditional elements, and costs are decreasing, making it a critical tool for understanding why a system is mineralized and giving geologists the confidence to drill deeper, targeting deposits that remain entirely blind at the surface. So there you have it, 5 modern techniques, from the soil under your boots to the cutting edge of isotopic analysis. Master these, and you'll dramatically increase your odds of spotting the next major mineral discovery.
Start explaining the whole 100%, 99%? Or... No, no,
Please.
Okay, then. So, 1, 2, 3, go. We're not trying to cheat Mother Nature. That sound scared me. So, usually more than 90% of that material is just waste. I mean, it doesn't contain any information. So any technique that we can use to concentrate the heavy minerals, which are usually the ones that carry the mineralization, will help us get better results. We are enriching the sample on purpose, which is what we need to get good results from the lab. So normally people do the panning. And for the pan, by the way, I didn't explain the first time. If you're going to do panning normally, instead of the little cup, you have a bucket of 10 liters. And the rest is the same. So, but it is important to always have the same weight. Sorry, the same volume. Okay? So 10 liters, you're doing a normal pan, something like this, that you later find out how many cubic centimeters are here. So, and you need a balance. So you fill the material, you weight it, you got volume by weight, gives you the density of the rock. And even that may tell you immediately if there is something good or not, because the more dense the sample, the most important it is. Actually, there is another thing that I forgot to explain, so it's good that the camera turned on. Okay, where do you get the sample in the river? This is a mechanical anomaly, so you need to apply a little bit of physics. You need to sample in places where the water in the stream accelerates, but not too much, accelerates enough to wash the light fraction, or stops enough so the heavy fraction will fall. So good places, an obstruction in the river, like a falling tree, that is usually one of the best places. You pick it up before the water. I mean, the trunk is here, the water goes here, you get it from here. Okay, so that is one of the best. The second thing to know is that the river always do meanders, and from one side he erodes. There, for example, it's eroding there, and then it deposits on the opposite side. So you take the sample from here. This is a good sample. Within the area, try to find out where you see rocks like this. Okay. And I know this is a problem because all these rocks need to be thrown away, but here, in this piece here, is your best concentrate of heavy minerals in the whole size here. So you see, there, wherever you see rocks, that is where you're going to take the sample. You see over here, there is nothing. Okay, so those are the important things. So, okay, let's go back. So as I mentioned, we're gonna, this you do it in the field, but because we have this sample taken before, we will fill this up. You hit it like that, so it will hit it. So that is your sample. So the next thing, you weigh this, and you know how much it weighs. Then you take, usually take something a little bit bigger, longer at least. This is 2 square. So you take a sieve of number 4, which is about ½ an inch. Okay, so you can throw away all the big rocks. So there is the sieve, okay, the invisible sieve. And then we need to make sure that this, we're going to take a couple of spoons, that this sample is representative of the meter you sample in the wall. So we need to homogenize this extremely well and then do quarters. So this I really discovered like a couple of months ago. A very easy way to do the homogenization is just grab this thing and then you put it up. You need to put it up. You need to put it up. No, sorry. So that. You need to do that so it will move. Okay. Okay. Now we do the same, but from this side. Be hard. It must rotate. It cannot slide. It needs to rotate. Okay. So you need to do like this. No, it's a brisk movement. Like that, okay? Brisk movement. Brisk movement. Ah! You got it. You got it. Okay, perfect. So now that it's well homogenized, we just distribute it. Make a quarter. By the way, I'm doing something really bad. Contamination. Okay. And you just throw away 2 parts. And this is your sample. Okay, so we're going to take the sample from here. So, for that, we take a condom. Actually, this is the box. Power play. This is the one that you're going to need. Because all the other one has some forms, strange forms, and smells and stuff like that. We don't need that. So you just fill the condom with water from the river. Come on. And as I said before, the best one if it doesn't have any oil on it. But if not, we work with what we have. So now that we have the condom with about half the weight water, we just add the spoons of material. I will let you do completely the full one from the side for yourself. Now remember, the tip, grab the tip.
I can't use this spoon anymore, I must pack it.
Actually, it's amazing. It takes enough material. So, if you see, there is no sorting there. They are just like they. So, we grab the condom here, and when I'm gonna do this first movement, and then I'm gonna lift the tip, and we're gonna do a vertical movement. Practice safe geology. So 10 seconds, 15 seconds, really, you don't need too much. And when you finish, you will see that all the heavy fraction have concentrated right here. And all this is like material, clay, etc. So basically by 50% minimum, you have concentrated the sample with the thing that you need. Now, to get the sample, you just grab it from where you want to get. Sometimes you are interested in the really, really heavy ones, you just grab the little pit, okay? If not, but at this exploration now, grab all the whole thing, throw it away, and that is yours. Finish.
Welcome to my channel, where you'll find over 2,000 videos on geology, geochemistry, AI, and many other subjects. If you like what you see, help us grow by subscribing, liking, and sharing this channel.
YouTube elimina la barrera de los idiomas. Ahora ya puedes oír los vídeos en tu lengua materna aunque estén en inglés. Sigue estos pasos sencillos. 1. Abre el video en YouTube que quieres mirar. 2. Haz clic en el icono de los subtítulos. Parece una pequeña CC, está abajo a la derecha del vídeo. Si los subtítulos están en inglés, haz clic en el icono de configuración, el engranaje, también abajo a la derecha. 4. Selecciona Subtítulos y después elige Traducción automática. 5. Busca y selecciona Español en la lista de idiomas. ¡Listo! Ahora puedes ver y entender cualquier vídeo en inglés, con subtítulos en español. Así, YouTube te ayuda a aprender sin importar el idioma original del video.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.